you see it getting sharper and sharper and sharper. And you guys saw this in your lab. This is diffraction grating. Let me pass it out. Please handle it by the edges. There's a rule in optics. Whatever you touch gets destroyed. And it's especially true of diffraction grating. Whatever you touch is destroyed. So please handle it by the edge. What that diffraction grating is this. It's that N slit with N taken to a very large number, like 1,000. So for that diffraction grating you are holding, I think it's 1,000 lines per millimeter. So if you have this laser beam of 1 millimeter in width, as it's going through a 1,000 of those slits. So it's as if I took this and made this 1,000 instead of 100. Oh, I guess I haven't tried that either. Let's see. Hopefully it works. I don't know. This is a free product. It might, at some point, limit my computation time. Oh, never mind. It works. OK, so this is where it's beginning to run into calculation artifacts. It's a sampling error. So let me not do that. The free version of Mathematica is not able to handle this the way I want it to. All right, so let's just leave that there. Can I get I forgot to take one for myself. Is there one left at the end? Yeah, there's one. Thank you. Yeah, there's more than one left. All right. So with this diffraction grating, you see two things. One, this D is usually very, very small. So the very first thing you see is that this first principal maximum is going to be at a very large angle. You saw this in the lab. When you pass this through, so the first principal maximum is way over there. That's the first order interference maximum. That's the first order interference maximum. So it's already at like a 20, 30 degree angle. So that's the one thing. The other second thing is what we saw here. With a large number of N, the interference, constructive interference peak becomes very, very narrow. So essentially what you see here is with the size of this beam, the interference maximum you see looks more or less like the same beam you see in the middle, except not as bright for some reason. Yeah? I had a demo I wanted to show. So with this diffraction grating, so this is what it is used for. I guess if you take this and look at the light, you might see some light, but so I made this device that's more designed to do that kind of measurement. If I can show how this works after the class, maybe. I think the better thing to demonstrate the use of this diffraction grating with is this atomic, I guess, vapor cell. So this is this tube is filled with the helium gas, and when I turn it on, it's going to produce a particular kind of light, neon light, and aside from having a yellow color, the spectrum of this is actually pretty unique. Let me turn off the other distracting light, and you'll be able to see. I recommend that you hold your diffraction grating horizontally. So the writing should appear horizontal. And put it right in front of your eye. Look at the light. If you need to block the other lights from around it, and look for, so you will see the yellow line in the very middle. That's not anything, but look to your left or right. You will see other similar short vertical lines that has yellow in it, but it also has other colors in it. Can you see it? So Sungmin, where you are might be a little bit too far to see anything. But do people see those other additional vertical short lines? Yeah. So that's what this diffraction grating is doing. It's separating out the wavelengths from this according to the, this formula here. So it's it's dependent on the wavelength. So, so see if you can verify this. The shorter wavelength should diffract less, right? So as you look at it, the colors that's closer to the central maximum should be the blue colors. Is that the case? right? And the red colors in the rainbow are farther away from the central maximum.
Yeah, so I found the blue one on the right side and
Yeah.
then the yellow one.
Yeah, so yellow should be right in the middle. So this exact yellow color, that's the mixture of all those different wavelengths that get separated out by this diffraction grating. So, so that's a diffraction grating, and we are actually going to use this or a version of this later on when we do atomic spectra lab. It relates more to quantum mechanics. But so that's the tool we are using. So I want you to take this chance to show you the tool before we use it, like a month or so before we actually are going to use it.